So, dear students, today we will solve some numericals on quantum mechanics based on the de-Broglie formula. So, the first numerical is find the voltage that must be applied across an electron source so as to produce electrons having matter waves of wavelength 0.4 angstrom. Let us solve this numerical. So, we know that the expression for the wavelength of electrons at low speed is given by the following formula. So it is lambda is equal to 12.27 angstrom divided by square root of accelerating volt. So given to us is that the wavelength of the electron that is required is 0.4 angstrom. So if in this expression we put the value of lambda is equal to 0.4 angstrom, then by doing the cross multiplication and simplification we will get the voltage 946.96 volt. This is how we will obtain the wavelength of the electron when it is accelerated. Let us do the next problem now. So the second problem is very similar to the first one, except the fact that now in this case the charged particle is proton instead of electron. We want to produce protons whose matter waves have wavelength 0.4 angstrom, and we will like to find the accelerating voltage. Let us now do it. So the expression for wavelength of a charged particle at low speed is given by lambda is equal to h upon square root of 2q mv. Here q is the charge of the charged particle, m is the mass, and v is the accelerator. And if we do some simplification, since we want to find the voltage, after cross multiplying and simplifying, we will get the expression for wavelength to be this, that we will get the formula for accelerating voltage to be this one, that is accelerating voltage is equal to h by lambda whole square and multiplied by 1 upon 2 q m. So it is given to us that the wavelength required is 0.4 angstrom, h is Planck's constant, q is charge on proton, we know its value is 1.6 into 10 raised to power minus 19 coulomb, and mass of proton is 1.67 into 10 raised to power minus 27 kilogram. Let us put all these values in equation number 1 and see what the answer for voltage comes. So when we will put the value of Planck's constant, here it will be the value of required wavelength. Then these are the values of charge and mass of the proton. This is the required voltage. Thank you.